Okay, in this video we're going to look at examples where we're integrating the product of x to the power of n and an exponential function. So x to the power of n and exponential a times x. So the first example we look at is the integral of x times exponential x dx. So once again we have our formula up above here, the integration by parts. So we need to first of all identify u and dv. And then from those, we need to work out v and du. So we can plug those into the formula. So if we come up to a rule at the top, if one of the factors is a log function, this must be taken as u. That is not the case here. It's no log function, so we move on to the second rule. And you go to the rules in sequence. Rule number 2. If there is no log function but a power of x, this is taken as u. So we see here we've x to the power of 1. So we can let that equal to u. And of course that's equal to u. dv is whatever's remaining in the product, so it's exponential x dx. Then on the left hand side I can differentiate say du dx, which is equal to 1. That implies that du is equal to dx. Over here, we can integrate both sides of this. So, just use the color code and follow. So, dv, the integral of dv, times the integral of exponential x dx, gives us v is equal to exponential x. So now we have these values that we can plug into our formula. So our formula says u dv is equal to u. So u is equal to x times v, which is exponential x, minus the integral of v exponential x times du. du is equal to dx, taking the values down, etc. So once again, this is u, v minus the integral of v du. So if I tidy that up, that gives us x times the exponential of x minus, on the integrated side, the integral of exponential x is exponential x plus a constant of integration. And here we can factor out the exponential x. So it's exponential x minus 1 plus a constant of integration. In this example, we're integrating a product of x times exponential 2x. So as before, we need to identify u dv and u dv, and from that we can work out v and we can work out du, which we need for our formula, the integration by parts. So we follow our rules. We go to the first rule. If one of the factors is a log of x, this must be taken as u. Well, there's no log of x here, so we move to our second rule. If there's no log function but a power of x, this is taken as u. So we have u is equal to x, and that leaves dv is everything else in the term, which is x to the exponential 2x dx. If we come along on the left hand side, we integrate du, so we get du dx is 1. That implies that du is equal to dx, which we're going to need for our formula. On this side, we can integrate both sides because we're looking for v. So I apply the integral sign to both sides. That implies that v is equal to exponential of 2x divided by 2. So now I have the values that I need to plug into the equation. So u dv, let's scroll down a little bit so the equation is still in view, is equal to, the first one is u, so u is x, then we're looking for v, is exponential 2x over 2, minus the integral of v, which is exponential 2x over 2, times du, which is dx. So that's u, v minus the integral of v times du. So if I work that out, that gives me x times exponential 2x over 2 minus, and I can take out the half, and I can integrate exponential 2x, so I get exponential 2x over 2 plus the constant of integration. So I've taken out the half, and then when I integrate exponential 2x, I get exponential 2x over 2. So if I then just factor out anything that's common, so what's common here is exponential 2x over 2 times x minus a half plus a constant of integration. And as before, if we don't want to deal with a half there, we can say that's exponential 2x over 2 times 2x over 2 minus 1 over 2 plus a constant of integration, so we multiply above and below by 2. We now have a common denominator, so we can write that as 2x minus 1 over 2 plus a constant of integration. We can finish off by taking the 2 here outside, multiplying by the other 2 to give us 4 times 2x minus 1 plus our constant of integration. So that's the solution for that one. That is the integral of exponential x times exponential 2x. So x times exponential 2x dx is equal to exponential 2x over 4 times 2x minus 1. It can be deduced from this result and the previous result that a general formula will arise where x times the exponential of ax dx will give a result as follows. It's equal to e times ax over a times x minus 1 over a plus a constant of integration. So that's what you see back up here. And then the following steps I taught you a little bit. But it's just that this could give you this general formula here. That would give us the general formula if I tidy it up. The exponential ax over a squared times ax minus 1 plus a constant of integration. In this example, we have the product of x squared multiplied by exponential x. So we're going to use a formula for the integration by parts. So in this case, we're going to have to figure out which one we're going to select as u. So we come up to our first rule. If one of the factors is a log function, then this must be taken as u. Well, neither of these functions are log functions, so we move on to our second. If there is no log function but a power of x, this is taken as u. So you can see here we have x squared. So we say u is equal to x squared. And then that leaves us with dv is exponential x dx. Follow the procedure. We need to figure out v. We have u, but we have dv, but we need to figure out v and du. So to get du, we differentiate this term for u. So u is equal to x squared, du dx is equal to 2x. And that implies that du is 2x dx. On this side, we need to get v. So we integrate both sides. Exponential x dx. We apply the integral sign to both sides. We get v is equal to exponential x. So we now have the values we need, or the terms we need to plug them into the formula. So u dv is equal to u, which is x squared, times v, which is exponential x, minus the integral of v, which is exponential x, times du, which is 2x dx. And this gives us, if I tidy it up, gives us x squared exponential x minus, I can take 2 out from the integral here, but I'm still left with x times exponential x dx. So I just bring the x to the front. So what happens here is we have this term here. Now we have to go around again, and we have to follow the procedure again when we now integrate this term again. And when we get our answer, we plug it back into this equation. So I'll number this equation 1. Then what we need to do is go through the process again, separate time. So now we have the integral of x times exponential x dx. So we're going to use our formula again, so we have to identify u. And once again, we follow our second rule. If there's no log function but a power of x, this is taken as u. That's our second rule up there. So if I come here, u is equal to x, that means dv is exponential x dx. Everything else in the product. Once again, we have to get u and v, so differentiate this. U dx is equal to 1. That implies that du is equal to dx. On this side, I can integrate both sides, so integral of dv is the integral of exponential x dx, and that implies that v is equal to exponential x, like so. I now have the terms I need to plug them into the formula, so the integral of u dv is equal to u, which is x, times v, which is exponential x, minus the integral of v again, exponential x, du this time is just dx. So you can see this time around we can integrate the term directly inside the integral, so it's exponential x plus our constant of integration. So this is our second formula here. This is the integral of x times exponential x dx. That gives us 2, which is number 2 here. Then we say, the next line, we then substitute 2 to 1. Equation 2 into 1. So that tells me that, do it again here, that the integral of x squared times exponential x dx is equal to, and I take it from up here, exponential x squared exponential x minus 2, and then I open up a set of brackets and get the minus 2 from up here, and then I put in the result that I got here, the integral of exponential x dx. So now I'm going to take this here, and I'm going to substitute it in here. So I get x times exponential x minus exponential x. I can put my constant of integration in here. So then, tally that up, I get x squared exponential x minus 2x exponential x plus 2 times exponential x plus the constant of integration. Each of those terms has an exponential x in it. So I can factor out the exponential x, and just skip down here to do it. That's equal to exponential x. I factor it out of the first term, I get x squared. I factor it out of the second term, I get minus 2x. Factor it out of the third term, I get plus 2. And out here I have my constant of integration. So that